Good day, my students, and welcome you back to this wonderful class. More so, I want to welcome you to Eko Learners Support for WAEC and NECO candidates. My name is Olusola Joseph. I'm your instructor for today's program, so I want you to sit back and let's enjoy this class together.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So what are we going to be discussing today? It's going to be a continuation from our last class. We started on saturated hydrocarbon. I hope you remember when you mentioned alkenes and the alkynes. So today, we'll be talking more about alkynes. Good. Let's go on. Basically, I'll be discussing about nomenclature of alkynes. How will you name alkyne? The first thing you need to know is their general molecular formula. So their general molecular formula is CnH2n-2. You remember where N is any whole number. But in this particular case, N is going to start from 1. When you have 1, it does not exist in this family. So their first member is when N equals to 2. So when N equals to 2, you have C2 H2 times 2 minus 2. And that will give you C2 H what? 2. Good. C2H2. And the name, it implies that we have what we call a time. The A and E has been replaced with what? Y and E. And this is the structural formula of this particular compound called a time with what? A triple bond in between. And that triple bond signifies what? The functional group. So the functional group here is what? Triple bond. Fine. Let's move to the next slide. Let me pick my pen. Alkynes, it shows a high degree of what? Unsaturated hydrocarbon than alkenes. Why? You remember that they have what? Triple bond in between them. Therefore, there are 4 available electrons that make them more reactive than alkene with just 2, with just what? The double bond. This has just 2 available electrons. So in between the 2, you discover that the alkyne is more what? Reactive than alkene due to the what? The triple bond that is present in it. And that makes it to be chemically what? More reactive than even the alkenes or the what? Alkyne. You need to know that. So how do we name them? I've told you. They are named from what? From alkenes by replacing A and E with what? With Y and E. So that is very, very important. Instead of writing A and E, you change it to what? Y and E, as you have it here. Good. Also know that the first member of this family is what? Ethyne. I've told you when N equals to what? 2. With a structural formula of what? With a structural formula of HC, triple bond, CH. Wonderful. Now, how do we prepare the first member in the world in the laboratory? So you need to understand how it is being prepared. The first thing is the reagent we use in the preparation of this compound. So the reagent we use is called calcium what? Carbide with water. So calcium carbide with water. So why are we adding sand to it? Because it requires a lot of heat. So in the process, a lot of heat is generated. In order to absorb the heat, we have to put the sand inside the what? Inside the flask. What the sand will be doing is to absorb the heat by not allowing the what? The flask to break. So as the water is introduced, it goes down to what? To this particular what? Conical flask that contains concentrated H2SO4. What will this be doing? Good. Just what? To absorb the what? The water and dry the gas. Just to make the gas dried. So the dry gas is obtained by passing it through what? Through water. And you need to understand as well that this compound called ethyne, to produce it, you need what? A cold water on calcium carbide. And when this happens, what happens? The reaction is carried out on a heap of what? Of sand. I've told you why we are using sand in order to prevent the flask from what? Cracking. So what the sand will do is to absorb the heat that is being generated when the cold water is added to calcium carbide. And what happens? Ethyne is being generated. Now what is the chemical? What is the chemical reaction to this? Get to know this when we get to the what? Chemical properties of this compound. So what are the physical properties of what? Ethyne. The first one that you need to know is this. One is the colorless. Yes, gas. It's a colorless gas with a castrated what? Sweet smell. You can only have that when it is pure. Please, you need to know that. It's primarily soluble. You begin to know the solubility of this compound from alkane to alkene and to alkyne. From the alkane, it's more soluble, less soluble when it gets to alkenes, and what? Less soluble when we get to what? Alkyne. I've told you as well, the way it is collected by what? Facing up. We call it upward what? Delivery. Why? Because it's less dense than air, or less dense than air. The another thing you need to know, it is a gas, but it is unstable. And aside that, it may explode on compression to liquid. So when you are trying to compress it to liquid, you need to be more careful because it can explode when compressed to liquid. That is very important as well. Now, what are the chemical properties of this compound? Yeah, the chemical properties of this compound is very, very important. The first one you need to know is they undergo what we call combustion. Meanwhile, at this point in time, you need to know that all the hydrocarbons actually undergo what we call combustion. And when it happens, it must give what? You remember? Somebody is telling me water and carbon dioxide. Good. That is, you can pick, for example, we have it already here. So you can pick, for example, when you have these words, ethyne. So when you have this particular ethyne combining with what? Oxygen. So what's going to give? It's giving water and it's giving what? Carbon 4 oxide. So the equation must be balanced. When you look at the carbon there, it's 2 with the coefficients of what? 2. So 2 times 2 will give you 4. So in this particular case 2, we have 4. Then when you look at the hydrogen, the 2 times 2 will give you 4. So this hydrogen 2 is giving you what? 4. Then when you look at the oxygen, 5 times 2 will give you what? 10. Then when you look at this, you have 2 here. Then plus, you have how many here? 8. All together, we equally give you what? 10. So the equation is balanced. You need to know that in this kind of reaction, combustion of any hydrocarbon, we give water and carbon 4 oxide. Good. Let's move to the next. Yes, you need to understand that they are unsaturated hydrocarbon. So basically, they undergo what we call addition reaction. So the first one is reaction with hydrogen in the presence of what? A nickel catalyst. What would the reaction be? Yes. How would the reaction go? Good. If I have C2H2, as you know, then I pass 3 molecules of hydrogen gas to it in the presence of what? Nickel. So what we give is C what? C2, H what? Count. So this 3 times 2, 6. So what is it going to give you in this particular case? Okay, so let me use this to make it more easier for you. Let me go this way. Let me use their molecular words. Let me use the easier method for you. You have the, look at this. Okay, good. So I react it with what? Hydrogen. In the presence of what? Nickel. So the 2 molecules of hydrogen is needed. So in this particular case, the bond will be broken down to give. So that's 4 available electron. So all the hydrogen will go to the what? Available electron. So basically you are moving from what? Triple bond. You are moving from triple bond to double bond. To single bond. I mean, you are moving from to single bond. So you need to know this. So for you to move from what? For you to move from triple bond to single bond, you need 2 molecules of that hydrogen gas. And the process is called hydrogenation. And this is equally applicable to what? Halogen. So if you have triple bond H with what? 2 molecules of what? Let's say chlorine gas. You know what will happen? It will turn to what? Single bond. And this will be chlorine, this will be chlorine, this will be chlorine, and this will be chlorine. Then you have hydrogen, and you have what? Hydrogen. So what will you call this? 1122 tetrachloro what? Ethane. So it's very, very applicable. Also, when you have what? Hydrogen halide. So when you have hydrogen halide, the hydrogen halide reacts with what? Ethyne. As you have hydrogen, and you have what? Hydrogen plus HCl. Put what? How many molecules now? 2. What happened? I've told you, from triple bond, the thing will turn to what? A single bond. In this case, I'm going to have a single bond. Then this will be, these are the bond I'm going to have. So let's say this hydrogen, hydrogen. So the first one, the chlorine can come here, while the hydrogen is here. Then what happens again? The hydrogen goes to the side that is having higher hydrogen, and chlorine comes here. So you have what we call 1 dichloro what? Ethane. So you are moving basically from what? You are moving from a triple bond to what we call a single bond. Also note that where the hydrogen is going and where the chlorine is going. The first chlorine, we go to the side as having lesser what? Hydrogen, while the hydrogen will go to the side as having higher what? Hydrogen. And that's what is applicable in that reaction. Let me undo this and let's go to the next slide. Good. Reaction. We have a lot of reaction. Reaction with water. When ethyne is passed through what? Diluted tetraoxide 6 acid in the presence of what? Mercury. 2 tetraoxide 6 as a catalyst. The addition of water takes place to form ethanol. You begin to imagine. So I have C, I have H, C triple bond H. Then in the presence of what? H2. In the presence of what? H2O. Then acid. Look at it, that is forming CH3CHO. So how come are you forming this? So it's very easy. The water will split. So when it splits, the triple bond, what happens to the triple bond? The triple bond will be broken down to form a reaction like this. To form a reaction like this. So you have 2 hydrogen that you have here before. So water is coming. So this is 2 hydrogen from water and the what? Oxygen. And this is what we call the ethanol. Yes, you need to know that. So basically, when ethanol reacts with what? Water, what it forms is what? Ethanol. In the presence of what? Acid. Good. Also, you need to know that when acidified, when ethyne reacts with what? Acidified KMNO4, the ethyne, what? It decolorizes it from purple to colorless. Fine. Reaction with acidified KMNO4. So you need to understand the color of KMNO4. So the color of KMNO4 basically is purple. So what it does, it decolorizes the purple into what? Colorless. Also note that if the solution is in alkaline, what happens? The solution will turn towards green instead of what? So we turn towards green instead of, it will turn to green instead of colorless. But how does it happen? So let's go. You have H. So you have C triple bond H. Then with the OH, it's more or less easier for you to know that you have, what do you have here? You have the OH and you have the second OH. So what happened? The bond will be broken. So if the bond is broken, so you have OH. So you have another what? OH. Yes, and its solution turns what? Colorless. So what's the name called? The name is called ethene because of the double bond. 1, 2, diol. You become ethene what? This 1, 2, diol. What it has done, it has added what? OH and OH to the what? To the triple bond and turn it from triple bond to double bond. You need to know that with the help of what? Oxygen. With the help of what? Oxygen. So when you hear KMNO4, oxidation reaction. You are adding oxygen to the what? To the compound. Please, you need to know that as well. Then the next slide is polymerization reaction. Also, you need to know that when ethyne is what? Polymerized in the presence of what? Organometallic catalase. Yes, in the presence of what we call organometallic catalase. So what do we form? It gives what we call benzene. So the benzene is formed. It's very easy to know. This 3 times 2 will give you what? 6. Then 3 times 2 again will give you what? 6. You need to know this. So whenever ethyne is polymerized, it gives a compound that we call benzene. Good. Also, it can undergo a substitution reaction. It's only one that can undergo what we call a metallic substitution reaction. And you need to know this metallic substitution reaction is only applicable to what? Terminal alkyne. It's only applicable to what? Terminal alkyne. And that's what is going on here. When you look at this, you have H, C, triple bond, H. Then you have, so this will be replaced and this will be replaced by what? By copper. So one copper is coming here to give copper, C, triple bond, copper. And that's what you have here. With the production of 2HCl. So what has happened here? It has gone to turn what? Yes, it has gone to turn the solution to what? Reddish brown. So it's very, very important. Please note. But if it is not terminal, for example, if I have something like this, yes, I have something like this. So this CH3, this H3. Okay, fine. In this case, it cannot. Why? Because the triple bond is not at the what? Terminal. You need to know that. Also, you can react it with what? Silver triazonitrate what? 5. We call it ammoniacal silver triazonitrate 5 to form whitish yellow. It's what we call a metal substitution reaction. Also, the H, the triple bond, the H, we react with what? This AgNO3. So this will be replaced with what? Silver to give Ag triple bond CAG. And the color here is what we call a whitish what? Yellow. So this particular reaction is very, very important because it's the only way you can use to differentiate between the two unsaturated hydrocarbons. Remember, they both decolorizes bromine water and also KMNO4. But the only test you can use to differentiate the two is by passing it through what? Ammoniacal solution of copper 1 chloride or ammoniacal silver what? Nitrate. Fine. Now, what are the uses? So what are the uses of this particular ethyne that I've been talking about since? The first thing is you need to know that ethyne is what? Is mixed with what? Oxygen to produce what we call oxy what? Ethyne flame, or we call it oxy what? Acetylene flame with about 3,000 degree what? Celsius. So the heat generated is so high that it can melt any metal. And that's what you are seeing here. So basically, you should not forget that the ethyne, when mixed with oxygen, it produces what we call what? Oxy what? Ethyne flame or oxy acetylene flame with the production of about with the production of about what, 3,000 degrees Celsius. Then aside that too, it is used in the manufacture of what? Yes, PVC pipe. You need to get to know all this. Is very, very important. So let's move on. Okay, fine. Also, it's essential for those that will be doing JAMB in the future that use in what? In minor lamp as well. Yes, this is what? A time. It is used in what? Minor what? Lamp as well. Also used in what? In making synthetic what? Fibers. So all these synthetic fibers, yes, a time is used in making them. Good. So test for unsaturated hydrocarbon. I've told you already, so unsaturated compound decolorizes bromine water. Yeah, it decolorizes what? Bromine water. Now, evaluation. I want you to just digest about this. Give a chemical test to distinguish between ethyne and ethane. And write the balance equation to show addition reaction of what? Ethyne. 1 minute.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
I hope you've written your answer. So let's do it together. So what test will you use? Yes, I had somebody telling me you can use bromine water. Good. Yes, you can use bromine water, but it might not work here. Therefore, what we use? Metal what? We call metallic substitution reaction. And this is only applicable for terminal alkyne. Wonderful. So write the balance equation for one of the words, addition reaction of ethyne. So let's quickly do that. So I pick then I react it with what? Hydrogen gas in the presence of what? Nickel. So what do you have? So you have C2H. This one will be 2 molecules, H6. So from ethyne to ethane. Okay, good. So on that note,
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
I want to say thank you for your time. In case you have any question, any suggestion, any answer, don't forget to share it with the link displayed on the screen. Bye for now.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.